Greetings everyone. In this video we'll be looking at geology versus construction. So when it comes to this topic, we will be looking at the natural effect towards the infrastructure. So when it comes to geology versus construction, I'll be looking at the environment and also the natural effect. So when it comes to natural effect toward the infrastructure, looking at earthquake. So if you are creating your infrastructure, let me say near a reservoir, so you might experience an earthquake. So earthquake, that's why most of the time you have to make a research about the environment, to make a research before you start constructing a particular type of a property. So natural effects toward the infrastructure, the earthquake, then the second one, floods, and the third one, the natural hazards. And then when it comes to environmental effects, if you are creating a particular type of an infrastructure, you might experience a higher temperature. And the slope, the second one is the slope. Look, let me say you are creating your property, and that's and then the land of that environment is on a steep slope. So this is the steep slope is the effect, environmental effect towards your infrastructure. And then the third point, lack of water supply. Most of the time, the lack of water supply is caused by low rainfall, and also let me say you are creating your properties on a poor environment where the road is far from your property, so it's difficult for you to get water supply from municipality or government. So the lack of water supply. And then the fourth point, expensive material used to create those infrastructure. So these are the 4 points when it comes to environmental effects. Now we will be looking at the solutions when it comes to natural effect and also environmental effect. Okay guys, when it comes to the solutions of the natural effect for earthquake, let's learn how Japan defeats earthquake. So they use I will show you a video of on how Japan defeats earthquake. They use underground springs before they started the foundation of a building. And then the second point, I will just show you a complete video based on the solution of earthquake. And then when it comes to the second point, floods. When it comes to floods, just use a strong material. When you construct a particular type of a property, just use a strong material. Make a research before you start the construction. Make a research based on the environment. To avoid many challenges, to avoid the challenges of floods and many other natural challenges. And then when it comes to natural hazard, the solution is that use a gentle slope, use the second point, use a strong material, and also when you create the roofing of a property, make sure that you use a roofing that is pertinent to that particular type of an environment. Don't just use a roofing whereby when you experience a natural hazard, the wind force, just blew that roofing. So you have to make sure that the roof can resist the wind force. Yes, these are the solutions when it comes to the natural effect when you start when you are doing your construction. So now I'll just show you a video based on the solution of an earthquake.
Damage that does not cause human casualty is acceptable, and the designs are meant to protect lives. That is actually the minimum requirement in places plagued with an onslaught of earthquakes like Japan. Protect people. But how do they do it? To withstand these incredible forces, buildings have to be made to absorb as much of the seismic energy as possible, so they will not collapse. The process that mainly happens is called seismic isolation. Buildings or structures are set supports of shock absorption, which are sometimes as simple as blocks of rubber that are about 12 to 20 inches thick. This shock absorption works to resist the motions of the earthquake and take the pressure off of the buildings. They sit on rubber pads wherever they build columns down to the foundation. Adaptations to the base of the buildings are just one of the ways that buildings are made to withstand earthquakes. Motion dampers throughout the height, however, can also improve resilience. If you put dampers throughout, at certain levels like every other floor, you can reduce the overall motion of the building during an earthquake to a much smaller amount and prevent widespread structural damage. Those dampers look a little like bicycle pumps, but are filled with liquid rather than air. Compressing the pump pushes against the fluid, moving it slightly and reducing the vibrations. Often, designers of spectacular skyscrapers are reluctant to make the compromises needed to meet the seismic standards required by engineers. These complex devices, that excessive tension are not the only way to make buildings resistant, though many involve the overall layout and design of the building. For example, the more regular the building is, the better. Keeping all the floors a standard height and an even grid for the columns helps the buildings perform better in an earthquake. However, designers often have conflicts with engineering, as these standard designs often don't match their lofty architectural visions. Using mesh structures, for instance, is another way that they help prevent the building's supports buckling. If one part buckles, having that close neighbor helps stop bending and helps to fortify the building by distributing the energy evenly. Instead, one Japanese textile firm turned to carbon fiber rope. They developed a high-tensile twine from a carbon fiber composite. They sought to reinforce the structure of its new showroom and laboratory in Nomi. They worked together with Japanese architects Kengo Kuma and Associates to use rods of this material to help anchor it. They used a combined 1,031 rods attached to the roof. They essentially tethered them to the ground in a straightforward sort of way to help stabilize it with 2,778 rods inside. This may be the first time that carbon fiber has been used in this way. Still, the way they see it, it could be applied to flexible structures like wooden buildings that sway horizontally. The future of earthquake proofing. Creating truly earthquake-proof buildings is not going to be a static process. Researchers estimate how earthquakes might impact a structure in the future by continuing to observe activity at faults. 2021 has seen 2 7.0 or higher earthquakes so far, even as we close out the year. In February, one was at Fukushima, which was intense and deadly at 7.1, and then in March at Miyagi at around 7.0. This level of earthquakes is becoming more and more frequent, and seismologists will be tasked with the increasingly difficult job of predicting the unpredictable. The answer, it seems, lies in their gradual testing of the known technologies used to stabilize buildings. They continue to trail with creative designs such as the mesh mentioned above structures. Sometimes the testing is in smaller, more experimental structures, like the one with an elaborate polyhedral mesh designed to resist buckling entirely.
So guys, when it comes to solutions of environmental effects, for the first point of Earth, on high temperature, you have to do what you have to do a roof plantation. You have to do a roof plantation. And then when it comes to slope, definitely if you created a property on a steep slope, you'll experience a natural. Once there is a natural hazard, then that means your property will fly away just because you have created a property on a steep slope. Although this natural hazard depends on the direction of their movement, depends on the direction of the wind force. But you have to make sure you make a research before you create a property on that particular type of an environment. So when it comes to slope, you have to use a gentle slope. You have to use a gentle slope. And then when it comes to the lack of water supply, you have to create, let me say, a reservoir. You have to create a reservoir on the dead point. You have to create a reservoir to get water. Then when it comes to expensive material used for infrastructure, this material is used just because of the environment. You use that infrastructure, that material, to protect the infrastructure, not to collapse, not to experience natural hazards. That is the purpose. So here, the only way to survive when it comes to expensive material use for those infrastructure. For those infrastructure, you just have to ask for support to get the funding. Thank you guys for watching. Make sure you don't forget to subscribe and click the like button. See you in the next video.